Hey there, and welcome to exercise number 72. In this one, we need to write a function named bfsTraversal that receives one parameter as input. This parameter is an object describing the root node of a tree graph. Now, each node inside this tree has the following properties. It has a value, which is a number. It has a left property, which is a reference to the left child of this node, which again is an object with the same structure. But this property is optional because not all nodes will have a left child. There's also a right property, which is a reference to the right child of this node. But again, this one is optional because not all nodes will have a right child. Now, the function needs to return an array of numbers corresponding to the values of the tree in BFS order, so breadth first order. And I added a short note here saying that the left children should be visited before the right children. Now, if you've worked with trees and graphs before, then this is a problem you've certainly stumbled upon. But if not, I'm going to try to explain what's going on here. So even if you never heard of trees or graphs, stuff like that, you're going to understand and try to solve it. So let's look at the example first, but I also have a really interesting drawing for you to look at. So here's our root node, so the tree, which starts with value 1, and then in the left it has a node with value 2, which also has a left and a right, and so on. But this way we're representing here is not super easy to understand for us as humans. So I'm going to go here in Excalidraw, and this is the representation of the same tree. Now, I hope this makes a lot more sense, right? So we have here 1 that has 2 children, 2 and 3, 2 has 2 children, 4, 2 more, and so on. Now let's discuss about this BFS traversal. Now you can Google it online to understand how you should do it. I mean, what's its definition, let's call it. But I'm also going to try to explain it here. So BFS means we're going to start traversing the tree from the top, level by level. So first we're going to traverse this level, then this level, then this level, and finally the last level. And we're only going to move on to the next level once we've finished with all nodes from the previous one. So let's start here and put the nodes in order so we can see what the result is. So we start with the first level, so number 1. Okay, that's correct. Then the second level has the children of 1, and we have 2 and 3. But which one we put first? Well, in the example, I said, note, the left children should be visited before the right ones. So I'm going to put 2 and 3. Now we're going to move on to the next level. So we again start from the left. So the left children should be visited before the right ones. So I'm going to do 4 and 5. And then 6 and 7, right? So we go from left to right. And then finally 4 and 5. And then finally the last level, which is going to be 8, 9, 10, and 11, right? So this is our BFS traversal, right? And we traverse the entire tree, starting from the top, going level by level with the left children first and then the right children. Now going here, we can see this is the expected output, so numbers from 1 to 11. And in Excalidraw, we also arrive to this output as well. Now, if you want to solve this exercise for yourself, which I highly encourage you to do, then click on the link in the description. If not, keep watching and we're going to solve it together. I'm going to go here into the right side, into the code area, and let's first create an array with values in order. This is where we're going to put the values and we're going to return it, right? So this is the boilerplate. Next, I also want an array with the nodes we still have to traverse, right? Because I need to go through them and we're going to add them to this array. So we need to store someplace, okay, these are the nodes I still have to go. So I'm going to say const nodes to traverse is an empty array, and actually it's not an empty array, it's going to start with the root. So the root, we start from root to traversing. Now we're going to need to do some sort of a loop, but we don't know how many nodes there are, so we cannot do a for loop. Thus, we're going to do a while loop. So while we still have nodes to traverse, we can say, okay, the current node is which one? The one at position 0. So I also want to get it, but I also want to remove it from here because we only traverse each node once. So I'm going to say nodes to traverse dot shift. So this function gives me the node, the element position 0, but also returns it. Returns it. position 0 and deletes it. Now that I have the current node, I can say, okay, let's add its value to values in order. So values in order, push current node value. So that's great. But now we also need to go one level deep. So we are doing a while for the nodes to traverse, but those are the nodes, like, let's say, kind of thinking we have right now, but we may have nodes at the next level. We need to add them to this array. So we're gonna do if current node.left is different than undefined, because I said here it's optional, so it may be undefined. But if it's different, I'm gonna do nodes to traverse .push current node.left. So I want to also traverse the left node in the future, right? Put it to the array. And we're gonna also do it the same for the right. Now, this is very important, the order we're doing it here, because if I would put it in the reverse order, it would go to the right node first and then to the left one. But as I said here in the description, we should go visit the left node first. And to be honest with you, this is pretty much it. So let's test our solution. I'm gonna copy the object from here and just do console log bfsTraversal of this one. And we get an array from 1 to 11, which is the same as here. So that's correct. Now let's also test our solution, and voila, it works. Cheers, and see you in the next one.